A differential equation is a mathematical statement that involves an unspecified function and its derivatives. It expresses a relationship where the rate of change of an unknown function is related to the function itself, or simply a differential equation is an equation involving unknown function and its derivatives. For example, d square y over dx square plus xy dy over dx square is equal to 0. d4x over dt4 plus 5d square x over dt square plus 3x is equal to sine t. Partial u over partial s plus partial u over partial t is equal to v. Partial square u over partial x square plus partial square u over partial y square plus partial square u over partial z square is equal to 0. The differential equation is categorized into two main categories: ordinary differential equations, or ODE, and partial differential equation PDE. Ordinary differential equations: a differential equation involving ordinary derivatives of one or more dependent variables with respect to a single independent variable, is called an ordinary differential equation. Examples: dy over dx plus y cos x is equal to sine x. d cubed y over dx cube plus 2 sine x dy over dx plus x is equal to 0. First two examples of differential equation are also ordinary differential equations. A differential equation involving partial derivatives with respect to two or more independent variables is called a partial differential equation. For example, partial square y over partial x square minus partial square y over partial t square is equal to 0. Last two examples of differential equations are partial differential equations. Our concern is first to solve ordinary differential equations. But before starting ordinary differential equation, it is very important to know some basic things like what is order, degree, how to denote differential equation, and what is the solution and its types, initial condition and boundary condition. We first discuss such things as what these are. What is the order of a differential equation? The order of a differential equation is the highest derivative appears in the equation. The order of the first differential equation is 2, while the order of the second differential equation is 3 because the highest derivative is 2 and 3 respectively. The degree of a differential equation is the greatest exponent of the highest order derivative that appears in the equation. Note that the dependent variable and its derivatives should be expressed in a form free from radicals and fractions. From the example of the partial differential equation has order 2 and degree is 1 according to the definition. Let's look at an example that is in radical and fraction form so that degree are easy to understand. 1 plus dy over dx to the power 3/2 is equal to d square y over dx squared. Taking square on both sides, the given differential equation become 1 plus dy over dx to the power 3 is equal to d square y over dx squared to the power 2. so the degree is 2 because the greatest exponent of the highest derivative is 2. The expression y prime y double prime y triple prime, and so on y raised to the power n represent first, second, third, and so on nth derivatives of y with respect to independent variable under consideration. For example, d square y over dp square. The independent variable is p, parentheses are used in y raised to the power n to distinguish it from the nth power of y to the power n. If the independent variable is time, usually denoted by t, primes are often replaced by dots. Y dot is equal to dy over dt, y double dot is equal to d square y over dt square, and y triple dot is equal to d cube. Y over dt cube represent first, second, and third derivative with respect to time. A solution of a differential equation is functional relation between the variables involved such that this relation and the derivatives obtained from it satisfied the given differential equation. For example, y of x is equal to c1 sine 2x plus c2 cos 2x is solution of the differential equation. Y double prime plus 4y is equal to 0. Differentiate y with respect to x. Y prime is equal to 2c1 cos 2x minus 2c sine 2x, and again differentiate y double prime is equal to minus 4c1 sine 2x minus 4c2 cos 2x. Hence y double prime plus 4y is equal to into minus 4c1 sine 2x minus 4c2 cos 2x plus 4 into c1 sine 2x plus c2 cos 2x is equal to minus 4c1 plus 4c1 into sine 2x plus into minus 4c2 plus 4c2 cos 2x, which is equal to 0. Thus y is equal to c1 sine 2x plus c2 cos 2x satisfied the solution of the differential equation y double prime plus 4y is equal to 0. Type of a solution, general solution, and particular solution, general solution, a solution of a differential equation which contains many arbitrary constants as the order of the equation. Example, y is equal to a cos x plus b sin x. A and b are constants. Particular solution, a solution obtained from the general solution by giving particular values to the constants. For example, if we plug in a is equal to 2 and b is equal to minus 1 in general solution example, the particular solution become 2 cos x minus sin x. Initial value problem, a problem involving a differential equation and one or more supplementary conditions relating to one value of the independent variable which the solution of the given differential equation must satisfy is called an initial value problem. For example, d square y over dx square plus y is equal to cos x, with initial value problem, y0 is equal to 0 and y prime 0 is equal to 1. Or another initial value problem, y1 is equal to 0 and y prime 1 is equal to 3, while the value of the independent variable is 0 at the both values. Similarly, the value of independent variables is 1 at both values. Since this is a second-order differential equation, we can take only 2 values of it. If we had a differential equation of third order, we would take 3 values for it. A problem involving a differential equation and 1 or more supplementary conditions relating to more than 1 values of the independent variable, which the solution of the differential equation must satisfy, is called a boundary value problem. Example: d squared y over dx squared plus y is equal to 0. The boundary values are y0 is equal to 2 and y prime pi half is equal to 4. The values of the independent variable values are different. In the next video we will discuss the supplementary problem of Chapter 1 of the differential equation by Schoen's outline, in which we will solve mathematically what we have seen in this video.